Hello everyone. We are team ApexS, and this is our project titled Explainable Context-Aware Sprint Planning System. In this 10-minute demo, we will show the problem, the working system, the deployment, and the final results. So our team members are Manav, me, Midul, Madan, and Sharvesh. We made sure that the work was shared evenly and each member will speak during the demo. Sprint planning is difficult because teams must balance business value, capacity, risk, skills, and dependencies at the same time. In many teams, this is still done manually, which makes the process slower and less transparent. Our solution is an explainable context-aware sprint planning system. It takes historical sprint data, extracts sprint-level context, learns team-specific weights, and then solves a constrained optimization problem to generate a feasible sprint backlog. For the paper evaluation, we used 4 frozen datasets with 18,036 stories and 486 sprint groups in total. For the demo, we focus on TAWS only because it is the largest dataset in the study with 14,738 stories, 343 sprint groups, and 673 dependency rows. So it gives the clearest end-to-end example of the system. The system has a React front end, a fast API backend, and supporting services for persistence and processing. The workflow is simple. Upload the TAWS dataset, configure sprint settings, generate a plan, inspect explanations, approve the plan, and export the result. This makes sprint planning more structured, traceable, and suitable for real agile workflows. From a technical point of view, the pipeline has 3 main stages. First, the context extractor. It computes velocity, completion rate, skill coverage, and risk trends from historical data. Second, the learning module converts those signals into urgency, value, and alignment weights. Third, the optimizer applies capacity, risk, skill, and dependency constraints to produce the final plan. Now, Midul will demonstrate the live workflow in the deployed application.
Thanks, Manav. So from now, I'll demonstrate the live workflow of our deployed system. First, this is our Netlify deployed front end. So here, this has the upload page. We are in upload page now, and here you can upload the data set. Now we are using TAWS dataset, which has around 19k rows of data in it. Yes. This is our dataset. Now it will upload into our system. Now we have on the second page, that is the configuration page. Here we can adjust the capacity on based on of number of workers. Like if you have 30 workers or 35 workers planned according in that week, you can adjust the capacity and also the risk threshold. What does it? This risk threshold amplify is that the maximum number of maximum threshold of the risk you can take in that particular week's workload, and still you will get a meaningful results. This is that threshold, and there are 5 skills mentioned here, like backend, front end, database, testing, DevOps. You can choose whatever you want, or you can just leave it as it is. Then we'll generate a plan from this configuration. This is the main stage of our application. First, the dataset is clean and loaded into our database. Then we extract the meaningful data from it. Using our ML programming, we'll learn the few information like that risk, what is that output, and what is skills needed, and what stores it's been dependent on. Then we'll use logistic regression to optimize the extraction result, and we'll move to the planning section. Here, you'll see the results. like what is the total value? 212.54 is the total value have been achieved through using the 30 out of 30 capacity as planned. And as of now, it's in the status. Once we approve this, we can export it for our need. Below, you can see all the plan quality checks, like what are the checks it have undercome before coming to this stage, like the risk threshold compliance. Is it passed? Yeah, it is. Then dependency satisfaction and so many things. If you scroll down, we'll see the actual plan stories what we have been selected, and each will have its point and its values. Next, if you go through, is that the explainability page. Now, Madan will continue on from this. So thank you.
So, hi. So one of the main novelties of our project is this view explainability. So over here, for every selected story, the system provides a reasonable explanation and a confidence value. For rejected story, it shows why the story was rejected, such as risk threshold and missing skill and unmet dependency or capacity pressure. So we can see why this has been rejected over here, and what will happen, what is the risk impact and the risk distribution, and based on it, and we could see why this was selected, and the confidence score of it, the value contribution, and the rejected explanations, everything has been provided. So the system exposes analytics views such as value versus risk comparisons and trend charts, so users can understand the planning decision in context. Technically, this explainability layer is not a separate dashboard. It is generated from the same scored candidates used by the optimizer, so the reasoning is consistent with the actual plan. So from our results on Tavos, the learned model produced a mean MA of 0.3027, so over here, and a mean R square of 0.15 and F1 of 0.87 score, and ROC AOC of 0.7, and moving on, across all the seeded runs, across all these multiple runs, multiple methods, and multiple data sets over here. So that tells us the learning stage is capturing a real completion signal instead of behaving like a fixed heuristic. So we also compare the learned optimizer against the weighted MILP, context only MILP, greedy selection and random selection. And we have learned that the MILP delivered 2.1373 business value units. So we were able to see it on the plan part. So moving on, so when capacity was removed, the plan was exploded to 3107 stories and 17,443 total value, which confirms the capacity constraint is doing the real work. So when risk was relaxed, the selected values and average risk both increased, showing the trade-off clearly. So the output is not just a plan, it is also a plan plus the reasoning and the measured behavior behind it. So the output, which is what helps us trust the team. So moving now, service will show deployment, testing and reliability and the final details. Service?
Yeah, so thank you, Madan. I will now talk about deployment and reliability. Our system is deployed publicly with a front end on Netlify and a back end on Render. We verify the deployment by testing the key actions upload, generate, explain, approve, and export. We also check the backend health endpoint and the API workflow to confirm the system responds correctly in the hosted environment. For this demo, we are showing the TAWS based pipeline only, which keeps the evaluation focused and reproducible. As an extra validation step, the repository includes a regression snapshot with 18 passing unit tests across the weight learning, optimization, and explainability paths, so the live demo is backed by a tested code base rather than just screenshots. This proves that the project is not only working on a local machine, but also available as a deployed application that can be accessed from the internet. In conclusion, our project provides a complete explainable sprint planning platform. It learns from historical project data, applies planning constraints, explains decisions, and supports approval and export. The result is a system that improves planning quality, reduces manual effort, and makes sprint decisions easier to review and justify. The paper results show that the learned optimizer consistently beats greedy and random baselines, while the explanation layer covers both selected and rejected stories. In this version of the demo, we focused on the TAWS dataset because it gives the strongest full pipeline example for context extraction, learning, optimization, and explainability. So coming to closure. Thank you.